Um, okay, so where should we start in terms of getting on the same page about what we're working on right now? Do you want me to kind of brief you on what I've been looking at and thinking about, or?
Yeah, I think that because I had my PTO and I was out for more than a week, I think that the best way to start is please tell me everything
Okay,
and
sure.
and let's start discussing things.
Sounds good. Basically, let's start on the issue. I'm working on this issue, and the fundamental idea is that at some point, when we have the ability to have a sharded GitLab, and it's sharded, assuming we're sharding it by top level namespace or some other horizontal sharding strategy, we need the ability to rebalance things and move them around. Initially, we're just going to have one shard, and it's all going to be a very big database of all the GitLab stuff. So we need some safe, reliable way to move things from one shard to another, and in this case, it'll be top level groups. So we want an efficient move operation. We looked into different approaches, and basically there's a few aspects to doing this efficiently. One, we kind of assume doing it through Postgres and logical replication is one of the most efficient ways to do this job, and not doing it through Ruby and selects and inserts and there's a million other problems with that, and I kind of listed it on the original issue that this all comes from anyway, but this is where we've landed on what we're going to do. And I talked to Nick about how to do this Postgres replication thing in a flexible enough way for what we need, which is we need to be able to ask logical database one for give me all records that have this namespace ID and this project ID, assuming this is kind of what we go with. So give me all records where namespace ID in this or project ID in this list, and I want to do an initial load of all that data to another database, logical database, and then I also need to get a stream of updates that matches this where clause so that I can apply them to my second logical database. At some point in time when I'm basically caught up, I'm going to pause writes using some locking mechanism. I'm going to acquire a lock to prevent anybody from writing to the first logical database for any records that match this. In the application land, that'll be anything that belongs to the top level namespace. We won't allow writes in the application code. And then I'm going to finish consuming the stream of updates and then move our sharding routing table to point to the new logical database for this top level group. So there will be like one logical database that shows where all of the shards, where the top level namespaces belong in terms of their shard. And so we can update that after the move is finished, after we do some validation checks. But for now, the trickiest part of this is getting all the Postgres stuff working, and that's what I've started with. This is what Nick shared, a blog post about, and that's what I've been reading, a blog post about how to effectively use replication slots alongside of a PG dump so that we can get a consistent snapshot. So, or instead of a PG dump, we can use that snapshot ID in the context of a repeatable read transaction, and then we get a snapshot of what the data looked like at the same time we created the replication slot, and therefore there will be no overlap between what we read from the database and what comes through in the replication slot. All right, that's sort of high level of what I'm working on. Any questions for now?
No. My only worry there is that if we have to use PG dump and that kind of stuff, whether we can do it without having to go so low level. And but yeah,
Yeah,
we will.
so yeah, I haven't quite figured all of this stuff out yet. I mean, one of the problems that I have so far is and this kind of relates to what you're saying, is that there is, this create replication slot that exists in PSQL, but it doesn't exist as a regular Postgres function. Now there is an equivalent called pg create logical replication slot function, but it does not give back a snapshot name. So according to these docs and according to everything I've found so far, I have to use this psql command and this, and we don't even have a good way to use this from Ruby right now. So I'm shelling out for, I mean, I've just started writing Ruby code to just hack together something here. But I've got to shell out because I can't figure out how to execute such things from Ruby, or haven't figured it out yet. PG dump, we probably wouldn't use PG dump, partly for the same reason, because we don't want to shell out, but secondly, it's actually gonna dump the entire database, and we only want to do a select for the specific rows that we're going to copy across. So we can actually do this begin transaction stuff. As far as I understand, we begin a transaction with a repeatable read isolation level. So I think we can do this through a normal Postgres connection. We can select anything we want. We can do any selects we want, and then at the end of it, we don't need to commit. We roll back the transaction or whatever. It doesn't matter because we won't have written anything. But basically, we can read stuff. I don't actually know what is the most efficient way if you had Ruby code that was connected to two, or any client code that was connected to two different logical databases. What is the most efficient way to copy data across? I don't know if Postgres has a mechanism where you can tell it to actually copy from one to the other, or you're going to be reading and writing, and that's the only way to do it. But
Yeah, so logical replication sounds like the most one of the most fast ways to do that, other than dumping everything and reloading it. So let's take a step back. I want to ask a few questions. So depending on the implementation that we're going to choose, moving a shard to another, a group, for example, to another shard, there may be something like 60, 70 tables that are related to that group. So
we could probably, I mean, we've got like 400 tables in total, so we can probably assume that like maybe even as much as half of them are going to be sharded tables. But in an ideal scenario, most of our tables will be sharded tables.
Yeah, so that means that we will have to move a lot more things than just one table. Am I right?
Yeah, we want to move it all in one go, and with
Yeah.
one consistent view of the data, such that, you know, when we do our initial load, as well as when we do the consumption of the stream of updates, we never violate any constraints that may exist. The data is always consistent.
Yeah, I agree. This is a tough one. This is a difficult one. Yeah. So I understand that this is important for us for the original sharding. It's not as important for day-to-day operations because groups don't change the parent, the root ascensor that often. Am I right?
Yeah, well, we'd probably use this. I mean, it's kind of hard to know for sure what we'll want to do, but I mean, we assume that we're going to want the ability to do live rebalancing of things in future as well. Like initially, we may split our primary into two shards, right? And then in this case, we're talking about taking half of it and moving it across. But later on, we might do automated rebalancing through various means. I mean, the first thing I can think is like the simplest approach will initially be we will create a new shard, and then we'll just want to move the GitLab org group across to that new shard, because we want to test it ourselves first. And I guess, I mean, that's just one way we can tackle this. And it also happens to be a very large group, so putting it on its own logical database makes a lot of sense. And then similarly with large customers, we may want to individually hand select them at some point in time and say, yeah, your group is so large that we're just going to move you to your own logical database. And I don't know, you know, they may also request it, and that's something we can do as well for customers that need that. And then, yeah, aside from that, you just get rebalancing kind of needs as an application grows. We're going to be constantly going, okay, well, now this shard is getting slightly too big. Let's move some groups off of that onto some other shards to rebalance things out better. That so I assume this will persist forever. Like this idea of rebalancing and moving a top level group to a new shard will be something that needs to exist.
Yeah, but that means that we have an additional sharding strategy on top of the namespace or whatever, which is constant and will not change. Or do
I
you mean shard? You mean shard as a server, not shard as the shard, the logical shard?
I mean, so when I'm saying shard, I mean logical database.
Okay, okay,
Um, and the current assumption I have is that all top level groups will be assigned to a logical database or shard, and then they can move between shards just for the sake of operational purposes, not because of anything they did as a user.
okay. So there are two different things there that and I'm asking you. I'm trying to get up to speed with the discussions in the team. So there is the logical sharding. So, for example, the fact that we are going to say that, let's say that we decide that we are going with 512 different shards for namespace ID. Let's say we sort by hash. We hash IDs so that we have a pretty normal distribution, let's say. Uh, and we decide that we have 512 different shards. This is logical thing. They cannot coincide in the same database at the moment. It's like partitioning now. Let's think
Yeah.
about it. So to start with, we say that we will use 512 different shards. And we start with all the shards leaving the same server, the same shard
Yeah, 512
data.
logical databases on one database server, sure.
Yeah, it's not. So one thing is how we move a shard to another database.
Server,
Am I right?
Yep,
To another
that is one
database
thing, and
server.
that's not what I'm focusing on, yeah.
Yeah, so this is way easier
Yep.
because it's just how can we move a database, which is more, it's not trivial, but it's more straightforward because you just have to take a full database and move it somewhere else. And the second part is having to rebalance and move a namespace and move something, an entity between two shards, and I mean them in a logical way here.
Yeah.
And so that's what I was asking you. So rebalancing means that we have to move things around, means that we don't only have as a sharding key the namespace, because that means that we want to also move things on top of using the namespace, which may be static and constant or whatever.
So the particular thing that is different to what you're saying, and it's why you're arriving at this conclusion, is that sharding based arriving at the shard ID using a consistent hashing algorithm from the top level namespace is not something we need to do, and it might not be something we do, because when you use consistent hashing from a namespace ID, you're kind of fixed, and you can arrive at shard imbalances that are just impossible to resolve due to the consistent hashing. This can happen. I mean, it happens for us a bit in Elasticsearch, where it's just like we have shards because we use consistent hashing. This solves one problem where it's like find the shard for this project is very easy to answer, but then some shards just end up being considerably larger than others just through statistical differences. And there is no automatic rebalancing you can do there in that. The only configuration you can do is either change your hashing algorithm or change the number of shards you have. But so probably I don't foresee us using consistent hashing. And there's another reason on top of that, because all the data is in one database today, and we need an incremental path to getting us to n shards. So we can't go, we've got what we've got today, and then next day we flick it over and we're on 512 logical databases with 512 shards. Well, at least I don't have a strategy for this. What we've been thinking our strategy would look like is everything just lives in the one database today, and we come up with, we don't use consistent hashing, and instead we use a table that maps top level namespaces to shards, and that's a static table, single table that lives on a single database server. Or it could be written as this sharding table can be written anywhere. It doesn't even need to be Postgres, but this is
Yeah.
This is
Okay.
the
Okay.
kind of idea.
Yeah,
So
I wanted to make clear that we are there. Okay, okay. That means that our sharding strategy does not depend on a on a
consistent
deterministic
hashing.
function. Let's yeah, and consistent hashing or something like that. So that's why this is more important because otherwise this effort would not be that important. But if we want to do it incrementally, this is very important, and that
Yeah.
excuses because we need it. We need it on first day one, but also we need it ongoing as we incrementally start moving things around.
Yeah, even if you went with consistent hashing, and I think that whatever we investigate here is going to be very important because even if you went with consistent hashing, and let's say you had, we can't start out with 512 shards. That's too much for probably many different reasons. But whatever you start with in terms of the number of shards, you're going to need to reshard and increase the number of shards you have at some point in time in the future. So more like there are reasons why we don't want to have 512 shards, but the simplest being that there are going to need to be cross shard queries and queries that query all shards, and that is just going to have terrible performance characteristics if you choose. Like we read the Instagram blog post where they pre-sharded to thousands of shards. They can do that because they had consistent hashing and they didn't have to do joins. Supposedly, at least in the case I'm thinking of, but.
Yeah, and as a small note there, we have the experience from the container registry. We ended up, it's going live in a couple of months from now, and we ended up choosing 64 partitions. It's not about sharding, it was just partitioning, because when we went to 256 partitions, the lookup queries that had to go across all shards, like for example, doing a delete and then going back, to cascade and check, were very expensive, even in partitioning, which is partitions in a single database. So I understand the problem and I agree. It's not cheap to go to say, let's do 10K shards. It's very expensive.
I suspect there's like some considerable overhead in Postgres and database connections, and like there's 100 other reasons why having too many shards will have an overhead cost for us that is substantial. But
so if we were able to eliminate all cross-shard queries, modern Postgres can go to 1,000 and will be okay. Maybe.
Yeah.
But the problem is are the cross-shard queries. That means that we will have to, in one go, to eliminate everything. And everything means everything there, not just 99%.
Yeah. And anyway, we don't know if we'll get to that, but yeah. So my thinking is, even if we end up with consistent hashing and a bunch of other, like ways that we can guarantee that shards are based solely on a consistent function of the top level namespace, we'll still need the ability to split shards when we want to increase our scale. And a split shard will probably use a similar set of tooling to what we're going to build here, which is to say we need to take a subset of a shard and move it to another shard online without downtime, using the most efficient tools possible, which is Postgres tools. And these same tools, I think, would apply in that scenario.
Yeah, I agree. Yeah. Okay. Sorry for the deviation. It was very helpful for me. It's also helpful for me to understand
I mean, these aren't all like decisions we've written down either. I'm just kind of connecting up conversations I've had, because if you, I don't know if we talked about that specifically in the last meetings, but in some of the meetings I've had and I've spoken to people, like I'm getting this idea that what we're hoping will happen will be that we just move one group and we test how that group does in a new shard, and so all of this in my mind is kind of pointing away from consistent hashing and towards the idea of a mapping somewhere.
I agree, and I don't know where we have gotten with our discussion on horizontal sharding and partition. On horizontally splitting the database, but it's very expensive, very difficult. I don't know how easily we will be able either way to do this.
None of these look like easy solutions, and we're like, at least everybody on the team is focused on kind of understanding a different part of the problem space right now. And so what I'm working on is assuming all of the other problems were solved, how would we move groups between shards? So yeah, that is where I am at. I'll show you kind of what I've got code-wise, and this is just like hacked together. I only got this half working, and then I messed something else up. So, like I'm imagining we're going to have something called a top-level group move worker in Sidekick, and this Sidekick worker will be given a top-level group ID, and it'll need to be responsible for moving that group with minimal downtime to that user, using the most efficient tools we can. So in doing that, we have here, I had this working with this backticks, but I was halfway through writing this code in using popen before. But for now, I've got a pSQL out, and this is all hacky and all hard-coded to my Postgres configuration. I'm going to run a create replication slot move group logical test decoding. This is from this blog post where it says the first thing we do is we create a replication slot, and then this replication slot gives us back a snapshot name, which corresponds to the snapshot of what it was when the replication slot started. And the next, we need to go ahead and read all of our data and copy it across somehow using that snapshot ID. You can do it with a transaction like so, or with a PG dump like so.
Okay.
So I have that command, then all these comments of what's going to happen next. I'm going to try to extract the snapshot ID from that. Then here at the bottom, at the end of this thing, I have to drop the replication slot once we're done. Some bunch of things in the middle here that need to be filled out. Yeah, and here above was just my setup of what I had to do to try to get an environment. I figured I could probably test all this stuff with a single Postgres server and 2 logical databases, and I'm hoping that I can, so that I don't need to create another Postgres server locally and do it over there. But if I have to do that, I'll do that. I'll figure out how to do that somehow by just putting it in a different directory. But for now, I was like a bunch of commands to copy the schema only over to a new database with the same name. So I've got an empty database with the same schema. We've got a database, our primary GitLab development database, and I'm trying to copy stuff across. And I had to change 2 Postgres settings to get this to work. You need to change the wall level to logical, and we need to change the replication slots setting. Something sort of interesting that this reminds me of, this wall level logical, is that one of the next steps, once we have an algorithm written out in some kind of code, we need to validate that this algorithm is going to actually work at our scale on GitLab.com. So we have the write-ahead log, and we're going to use logical decoding, which is a plugin which sits there and reads the write-ahead log and transforms the data structures. And then we're going to have a consumer process that can read that transformed data structure. And the open question is, can we even use logical decoding in this algorithm at the scale of our write-ahead log? So we're going to have to benchmark it at some point. It's like another issue we have.
And the thing is, there is whether it will work in conjunction with how we set up our replicas right now and streaming replication. So at the moment we are doing and I'm talking GitLab.com only. So we have the main database, and we have the replicas, and we have the walls, and we play them back to the replicas. Whether this can play this new solution, we have to also keep the the replicas there, because we have to keep .com running.
Let me write that one down now, and I'll send it to Nick, because he's looked at this before and he may have the answer to this. Well, he explained how this is going to work to me the other day, but I didn't ask this specific question, which is how is this going to work? One of the things he did explain was we can only use, we have to consume the write-ahead log from the primary. There's no way to cascade these things through replicas, apparently, for what we're trying to do, which we can't create a replication slot on a replica. It can only be created on a primary. So therefore we put extra load on the primary, but additionally, can we create this kind of replication slot alongside of our other replication stuff? It's probably,
Yeah, and maybe in a week or so after things have settled down with the PG12 upgrade, maybe we can have a chat with Jose Finotto also and Nikolai together.
Yeah, that's going to be difficult time zone wise since Nikolai is in America and I'm in Australia.
Yeah,
So
yeah, or maybe include we can have Nikolai in there, and but also bring in Jose on our and yeah.
yeah, we can try to make things work async and see if we can find a decent time for all of us to talk. But yeah, we'll see how that goes.
Yeah, exactly. Nice. Yeah,
I
that's an
think
important question.
Yeah, and I think the answer is going to be yes, because when I read about this wall level stuff, so let me see, wall level, no, Postgres wall level, I, it basically says like you've got three settings: minimal, replica adds a bit more information, and then finally logical adds even more information. So what I suspect is
Pick
that
12. Sorry, but pick 12 because you never know what has
yeah.
changed.
Forgetting to do that. Yeah,
Yeah.
so same thing, but anyway, we can read this later. But my
Yeah.
assumption is it's just like how much data do you want to write to these wall files, and minimal to save yourself from some kind of crash or immediate shutdown, to recover from a crash or immediate shutdown. Replica is enough to support archiving and replication, so that's what we use today, and it's actually the default. And archiving and replication, I assume, is what we do today. But logical adds information necessary to support logical decoding, which is the feature we need. So my assumption when I read this is like, what the real thing that's going to happen here is when we switch it to logical, we're going to have much bigger wall files. I think, and then so that's kind of what remains to be benchmarked. If we actually do that, what could break at our scale.
Yeah, I agree.
But yeah, so each level includes the information logged at lower levels. So that's how I read this, but it's still a valid question about like, is there something in our current setup that is going to need to change in order for this to even work? But yeah, and then certainly the scaling aspect. I have to like click this stop share button.
Yeah, sometimes it's difficult.
Yeah, it doesn't want to be clicked. Yeah, okay, so I'm kind of like hacking together this Ruby stuff. I got, let me show you what I got here. If I just create, so like I can run these commands, create replication slot against my database, and they give me back a snapshot name, and then I can drop those replication slots. Yeah, I might take a second to kind of explain what I know about the logical replication. Is that logical decoding? Is that something you've kind of looked at before at all? This is seemingly somewhat new,
Yeah, I don't
magical.
know.
Yeah, this is the magic that's going to help us presumably implement the kind of really bespoke replication we need, because we're not trying to just copy whole tables from A to B and keep them in sync. We're actually trying to copy a subset of the tables that match a certain query. And my understanding of how we do that is based on decoding. So decoding is a plugin architecture in Postgres where they have implemented one such plugin called the test decoding plugin that comes with Postgres. The plugins, they are run on the server that has the write-ahead log, and when you create a replication slot, it is consuming the write-ahead log, transforming the payloads, and allowing you to encode that payload however you like. So basically, you can include all of the information you need in order to do filtering, so that your client who's consuming the replication slot, the consumer side, can read the payload. So one example is JSON, like they transform everything into JSON objects. There's a plugin for that. And then the client can consume that JSON payload and do filtering as they would need to, and it's done on a row by row basis, which I think is the important part. Is like, even if there's an update that happens to multiple rows, it will come back as single row updates through these things. So there's a server-side element to this where we may well end up having to implement our own output plugin or find a output plugin somewhere that is going to allow us to do what we need to transform the data in a way we need. I actually have no idea what test decoding plugin looks like, what the data looks like, and that's kind of what I'm halfway getting done now. But then what my assumption is going to be that we write a plugin that takes configuration options with a list of namespace IDs, and it just drops all messages that don't match those namespace IDs and keeps all messages that do match those namespace IDs, keeps updates for the rows that match those namespace IDs. And then the consumers of this, they just read the replication slot and they get only the updates that are important to them. So that's minimal over the wire data as well. Because the consumer is another part of this. It's something that needs to speak Postgres, and it needs to be able to execute these, that has get and peek queries, which can give you the latest update. So
interesting. And I don't know what overhead that will add. So at our scale also.
Yeah, exactly. This
that sounds great, but over our wall and our, the the pipeline, we have a lot of data there. I don't know what the effect will be in CPU costs, etc. Because as you just said that this has to run on master.
Yep, exactly. It's the one that has to run the output plugin. And we can try to make the output plugin as efficient as possible depending on the circumstances. But yeah, it is definitely one element of what we're going to need to benchmark. Because, and I spoke to Nikolai about this. He said that he's done this at quite considerable scale before, but maybe not our scale. And what will be interesting is to see, like, if the output plugin needs to consume the write-ahead log, if the output plugin like just physically cannot keep up with consuming the write-ahead log, then there will be no way we can do this. Using this technology, and possibly using any technology, we might have to have downtime. Would be the only remaining solutions I could think of, would be increasing downtime somehow. For the whole shard or something. This approach is to minimize downtime. Yep. Any more questions or thoughts?
No, that's great. Thank you.
Okay, I was creating this worker and I was just trying to keep running it until I got it to do what I wanted, and then I ended up with this. I thought I updated the code, but basically I'm trying to structure the same command I had. I had this command working here with the backticks, and then I was trying to write exactly the same command using popen3, and I seem to have the formatting somewhat wrong. That's kind of where I'm at now. It seems to say peer authentication failed for user replication database. So this is supposed to be the connection string that is being passed to the psql command, and I have the format wrong somehow.
Yeah.
I can't exactly figure out why. See, when I run this exact code, it seems to work. I'll prove that here. This is really probably just at this point a Ruby issue I'm having. New data performance step out. Okay. Oh no. That's weird. I had this working before, so now what have I done?
Okay.
I get it. This was working by doing this. Had -h. That was one change I made. I might end up having to undo this file to get it back to a point where I had it working, but we'll see. Okay, there we go. Oh, I'm still getting the error message though. I'm getting some more output here. That's weird.
Yeah.
And it's giving me this is what I want actually. It's giving me the thing, the snapshot ID. So this is sort of working, but I'm actually still getting this weird error message and I don't know how to interpret that. Peer authentication failed for Am I running? Okay, this is, oh yeah, here we go. This will be the delete command, which I didn't remove. Maybe this is what's actually been, I thought I commented that out before, and now I actually have a feeling that's what's been the problem the whole time. Okay, now I think I might be closer. Okay, no errors. Replication slot already exists. When I run it again, it'll create and delete it, because the last one was deleting it. All right, I have no more errors. Now, if I try to convert my thing into a popen command and print standard out, I maybe get an error, or maybe that error before was actually just move group does not exist. Replication slot move group does not exist. So this did not create the replication slot. Maybe because I didn't wait for this wait thread. I need to wait on the result of, let me just keep all of those, close all these things. The reason I switched to popen, what I'm trying to do right now is that the way this thing works is once I create a replication slot, it gives me back a snapshot ID, but Postgres will throw away that snapshot unless you keep your connection open. So I need code that's going to keep the connection open when I created the snapshot ID, and I'm going to use that snapshot ID in some other code, and I need to make sure I get that other code to execute before I lose my connection to Postgres. So right now, since I'm shelling out, which just makes this even harder to keep connections open, I'm using popen as a process that will hopefully keep me a Postgres connection. That's why I'm restructuring the code. Replication slot move group does not exist, and this is not creating my move group replication slot.
And also you need to have, which user do you use? The default one, the GitLab, you're running with a GitLab Postgres user?
It is just going to be using what is on my system right now, like the Unix default of my current logged in user, which, yeah.
Yeah, this is something. Yeah, but this is something to check afterwards.
Yeah, definitely. There's a lot that's gonna have to go into making this actual runnable code, but for now I'm trying to get the structure of the Ruby code to actually run. And let's see, this is okay. I'm gonna see if I keep reading standard out what happens here. Yeah. Reload this worker every time I change it. I have another meeting in 5 minutes, so after this call, I will just push up this hacky code and whatever. You can read some of the issues to try to get up to speed on this and see if you have any more thoughts about it in the meantime. But
yeah. Very interesting. Sorry, I could not help you a lot this time around, but next time maybe.
Yeah, I've been looking at this and reading about it, thinking about it for several days now. So yeah, probably have a bit of a head start on you, but
very interesting, and very interesting that we have to go that way. If we have to go that way, I don't think that we have ever gone. Outside of creating a connection with Postgres, a normal connection. So this will be a first one for us.
Yeah, there were a couple of things I was trying to, would be avenues to investigate. One, like a good client interface to pSQL that wasn't shelling out, if we really have to use pSQL. Alternatively, is there a lib pSQL that is some kind of C bindings that can be wrapped in a Ruby client if nobody has already done that? Thirdly, pSQL is presumably using some Postgres interface to communicate with the Postgres server. So why can we maybe, and this documentation doesn't explain why they don't, why it doesn't support returning a snapshot ID from the function that exists in Postgres, but it just says that it doesn't. So some other thing to explore is like, if we can figure out what pSQL is doing and just replicate exactly the same thing. It just, this documentation here, it says the creation of a logical slot using this function with a normal connection, it says non-replication. So one thing it did say is you need a replication connection. So maybe part of it, if we can connect to Postgres with a Ruby client using this connection string and request a replication connection, then maybe PG create logical replication slot will return us a snapshot ID, or maybe we need to just execute some more functions or something to get Postgres to give us a snapshot ID. I know there's such a thing as a PG export snapshot, and maybe that's what we actually need to be. Maybe PSQL is actually just doing a couple of things for us and returning us this convenient, simple thing with a single PSQL function. But that's kind of, I assume that this technically must be possible, or there's at least going to be better ways we can turn this into Ruby code than shelling out some way to do that. But yeah, we're going to be seemingly entering a world of much more complicated Postgres stuff when we're doing this. Orchestrating Postgres from Ruby to do cross database server stuff is going to be a bit odd. Yeah, I'm about to jump on another call in a couple of minutes, but any other things I can just catch you up on so that you maybe got something to look at in the meantime? Think about
I think I will follow the three issues, this one and the two others, and I will try to think about it first and then add some comments there. I think
and
that's the best way.
It's possible that we're off on a path that's way more complicated than it needs to be too. So, if you have other ideas about simplifying anything you see in here that...
Yeah. And we definitely we will need the help by Nikolai and Jose and the infra team, because that affects them a lot.
Yeah,
And
for sure.
there are things that we don't know about. So I don't know how this affects the infra team. So maybe, Jose or Jerry could tell us about it.